Section 3.8, we're continuing, and this time we're ready to show the derivative of logarithmic functions. Basically, we're driving the formula right here. Remember that logarithm function is defined by y is equal to log base b of x if and only if x is equal to b to power y. A lot of times people actually go this round thingy. They go b to power y gives you x. And so now that we have, we start with trying to take the derivative of y equal to log base b of x, and we don't have any tools to do that. So we can set up the we can also set up the limit definition. But it turns out one easy way of taking care of it is to find the inverse function, and that is use the definition of log base b of x, y equal to log base b of x, that's x equal to b to power y, and do an implicit differentiation. And that would be derivative of x is equal to derivative respect to x of b to power y. Derivative of x would be 1. Derivative of b to power x is going to be b to power y ln of b, that's the derivative of the outside function, times derivative of inside function, which is dy dx, that's the derivative y prime basically. Now when you look at this, you see that you can actually solve for dy dx and get the in that dy dx is the derivative of y function over there basically. And so that's the beauty of it. You take a function that you know, you do going from function you don't know, you take the inverse, you go to a function that you know, and you basically find a derivative. Now solving for that derivative will give you dy dx is equal to 1 over b to power y at natural log of b, or now that's the one that you got just from solving in here. So when you solve this, you got that, right? Now the next step though is to have because it's possible, it's not quite implicit, I have an explicit solution for y. I can replace y here, but what the value is right there, and that's the log base b of x. So b to power log base b of x, according to laws of exponential and logarithm, it's going to be x, and that's the formula. So again, the formula is derivative of log base b of x is equal to 1 over x natural log of b. And so what happens if b is e, if you're taking derivative of natural log of x? So if you're taking the derivative of natural log of x, this will be e, so this is going to be 1. So what you get is 1 over x. Golden formulas to remember: derivative with respect to x of natural log of b a natural log base b of x is equal to 1 over x natural log of b. Derivative with respect to x of natural log of x is equal to 1 over x. This is the derivatives of logarithmic functions. Example 5. Take the derivative of natural log of square root of x squared plus 1. So one way is just follow the formula, but remember this is natural log of another function inside, and so I can write it natural log of x squared plus 1 to power 1/2, and the inside function is x squared plus 1 to power 1/2. And so according to this law, what this is going to give us is dy dx is equal to dy dx is equal to 1 over x, right? This one says dy dx is 1 over x, but what is x? X is what is inside the function. So basically you write the derivative with respect to u of natural log of u, then you write du dx, and that is 1 over u, and du dx, this one is u, so that would be 1/2 of x squared plus 1 to power negative 1/2 times derivative of inside of that, which is 2x. It was a generalized, so this part came out to be this. And what is 1 over u? 1 over u is basically x squared plus is x squared plus 1 to power 1/2. And so this is one way of doing of solving for it. There's another way using your logarithmic laws, and so let's do that one also. More efficient way of solving this is using the laws of logarithm. So by laws of logarithm, because it's x squared plus 1 to power 1/2, 1/2 is going to come to the front. It would be a natural log of x squared plus 1. And then at this point, you can't simplify anymore, so you have to go back to this formula and take the derivative. So derivative of y at this point is going to be, again, it's the derivative of ln of u, or 1/2 is out here, but derivative of ln of u, which would be 1 over u, then times derivative of u, which is the inside, that's just 2x. So the entire thing becomes x divided by x squared plus 1. The other way that we solved it also would end up, after cleaning up, would end up to be x over x squared plus 1. But the beauty of knowing your laws of logarithm is that at this point it makes it a lot easier to deal with if you know them correctly and do them correctly, then you gain a lot by doing that and not going through all the other process basically. Example 5, part 2. Let's try to take the derivative of natural log of 2x. So first thing, there's no and there's one law of logarithm that I can use that makes y is equal to natural log of 2 plus natural log of x. And so now let's try to take the derivative of this. Dy dx is equal to u in here is going to be this part. This is u. So it's going to be 1 over u, 1 over inside, 1 over natural log of 2 plus natural log of x times derivative of u with respect to x. When you're taking derivative of u with respect to x, remember that natural log of u is a constant. So taking derivative of a constant is going to give you a 0. Taking derivative of natural log of x is going to give you 1 over x. So the entire thing becomes 1 over x times natural log of 2 plus natural log of x. And it's worth mentioning that natural log of 2 plus natural log of x is natural log of 2x. So that tells me that the final answer is 1 over x natural log of 2x. Example 5, part 3 now. Let's take the derivative of log base 10 of 2 plus square root of x. Not much to do, nothing to do with the logarithmic laws, so just let's use this formula this time. So if u is, let's say u is 2 plus square root of x, dy dx is derivative of natural log of log base 10 of u times u prime du dx. And so derivative of log base 10 of u is going to be 1 over u times natural log of 10. Okay, and then derivative of inside is derivative of 2 is 0, derivative of square root of x is 1 over 2 and square root of x. Okay, and let's replace u by its value. So 1 times 2 plus square root of x times natural log of 10 times 2 times square root of x. Example 5, part 4, and the last part, we're solving for derivative of natural log of x plus 1 over square root of x minus 2. So this one, the best bet is to start with law of logarithm. Logarithm of quotient is equal to the difference of the log. And so natural log of x plus 1, and this is 1/2, so minus 1/2 natural log of x minus 2. Then dy dx is equal to, this is natural log of u, and so it should be 1 over u, so 1 over inside times derivative of inside, which is 1. Example 6, logarithms and implicit differentiation. Use implicit differentiation to find dy dx if natural log of x times y is equal to x plus y. So as usual, when it's implicit differentiation, you take the derivative of both sides. So dx of natural log of xy equal to d dx of x plus y. This means natural log of u, which is it's a chain rule. Natural log of u times u prime, derivative of the left hand side is going to be that, and that's 1 over xy times derivative of xy, and derivative of x is going to be 1. Derivative of y with respect to x is y prime. Now over here it's I'm going to multiply xy by both sides, and so it's going to disappear from this side and be on the other side, basically by multiplying it. And then take the derivative of x times y, which is going to be derivative of x, which is 1 times y, plus x times y prime is equal to xy plus xy y prime. Now over here we put y minus xy together, and we put xy y prime minus xy prime together, so y minus xy is equal to xy minus x times y prime. So solve for y prime, and y prime is going to be y minus xy over xy minus x. This is one way of solving this problem. There is one more way of solving this. So let's do method 2. Let's erase and come back for method 2. Method 2 of solving the same problem. Raise e to the power, and it would be xy is equal to e to the power x plus y. Simplify this, xy is equal to e to the power x. Oops, sorry, this is xy equal to e to the x plus y, and do not simplify it, because and then you will have a product rule there, and so take the derivative of both sides with respect to x. One side, on this side I know we're going to get x y prime plus y, and on the other side you get e to the power x plus y times derivative of x, which is 1, plus y prime. And now solving through this, xy prime plus y equal to e to the power of x plus y plus y prime e to the power x plus y. And putting y prime together and y together, the rest together. Oops, sorry, there should be a negative sign. Factoring y prime. And then y prime is going to be equal to y minus e to the power x plus y and divided by e to the power x plus y minus x. So it looks a little different from what you have here, but you go back and notice that actually when you're solving, e to the power x plus y is x times y. And so that's exactly the same thing as that one. Again, I guess both numerator and denominator are multiplied by a negative sign, but exactly the same one. So let's do iClicker question 3. iClicker question 3, when you solve for y prime in an implicit differentiation problem, you have to solve a quadratic equation. A, always. B, sometimes. C, never. And the answer is never. Why, when you're doing the implicit differentiation, derivative always shows up in a linear form, not in a quad and not to power 2. Example 7, implicit differentiation with multiple quantities.